person, I don't think I'd be able to concentrate very well in the game if I was worrying about, paying for food. If I was like, oh man, I got to eat like brown rice this week because otherwise the game's not going to exist, then I'd be too wrapped up in that sort of crap, getting stressed out that when like the game doesn't work and I get frustrated, I'd be paralyzed. So what the hell are we actually doing here? All right, we're basically multiplying a y identity vector based on the wanted velocity's magnitude in the y direction. So we now have, if we're moving left or right, we're now going to add that to our new velocity. And we're going to multiply that by our delta t. So it's going to be new velocity plus equals our wanted velocity multiplied by delta t. And we should probably have a constant in here for like air control, like G phys air control constant. So we should do that. Make a bank work for Amazon? I'll just leave that at yes. When I left Amazon, I was walking away from a lot of damned money. So I was a senior engineer there, working on a project. I was running teams and all that stuff, so I walked away from a lot of damn money. You get salary capped, and then they pay you basically in stock shares. And the thing is, the stock shares don't vest for years, so you'll go there, and they'll give you, just $500,000 in stock, but it doesn't vest for 4 years. So you have to, if you walk away from it, you're just like, shit, man. I'm walking away from basically a damn retirement fund, and that can be rough. So I kind of had to just be like, what am I gonna do? I'm not 30 yet, and I want to do this independent game dev, and next year it's gonna be even more money to walk away from. If I don't do it right now, I'm never walking away. So you watch tutorials, you don't fully learn how it's supposed to work. Well, it's kind of like Adam. His last stream, he finally got on. Adam is the artist for my project. He finally opened up Unreal and started just like throwing crap in there and just doing it wrong, like just getting started. And you get paralyzed with a project where you don't know where to start, and you end up not doing anything and just being stressed. So just pick a point, throw a dart at a wall, and just get working. And that's the only way to do it. And also, making games is not about making money, at least for me. Making games is about making games. Because, if I wanted to sell my soul out, I'd go work for some high-frequency trading firm and, make, $300,000 a year and live in some high-rise apartment, do cocaine every night. That'd be pretty sweet, but I'm not ready to do that. So that's our wanted velocity getting added in there. So we got a little bit of control, and we're bouncing back and forth, doing our thing. Oh yeah, we're stuck in the wall. The A key is not jumping, it's like throwing me. And then the camera can't catch up to our fat sack character. I need to hire you. Should you clip that? You can clip whatever you want, Carrot Can. Alright, so we got our 1 of velocity there. Our character's doing kind of what he's supposed to. Our physics constants are totally screwed up. So the work I get to do is mostly farm work. Yeah, that's Fat Sack. He's a cool character. He is one of the little critters in the world of Brackenwood. If you don't know, Dashkin, the game I'm working on, is... If you ever saw the Bitey of Brackenwood animations back in Newgrounds, well, that's us. That's Adam. Adam's the artist who made all that stuff, and I'm the developer who is now working with him on making that stuff turn into reality. So no high school, GED. Well, nobody cares about your credentials in game programming or any of that. They care about your ability. And you know, when I went to college, I went to college at DigiPen over in Seattle, which is a very small, private, like 500-person programming college. When I went to college, I did not know any programming. Like, I showed up and I wanted to be in the advanced programming class because I'm real arrogant and shit, and I'm just like, well, I should be in the honors course. Of course, I'm smart. And you know, the teacher walks around, the prof is like, well, oh, paper does not freaking matter for a game industry job. It probably does matter for East Coast is different than West Coast. West Coast people tend to be a lot more strict on paper and stuff like that, and especially if you're going into normal engineering, like, you know, doing websites and all that, commerce, whatever. They usually look a little bit more, but West Coast guys, they don't give a shit. In fact, in some of the hiring situations, if you have a self-made programmer, you know they're motivated, and they were able to keep themselves focused outside of college. So you can actually, sometimes you'll take a closer look at what they got. But when I showed up to college, the advanced professor just came and said, like, well, do you know what a variable is? I'm like, I have no freaking clue. He's like, well, do you know what a function is? I'm like, no. I'm like, what? Why should you be in the advanced class? I was like, well, because I showed up. And he's like, okay, cool, you're in the advanced class. It's like, all right, crazy. And you know, just everyone else knew more than I did in college, at least to start with. First year there, I just like sat down with a book and just like was, you know, waking up at 8 in the morning and staying, you know, going to school and staying at school until 10 at night, just reading books, writing programs, learning what the hell I needed to do. And it wasn't like my college degree that made me learn how to program. It was just having people around you who know and help you and all that. Work on alternative careers. Oh god. We'll see what this says. I need to hire you. Should you clip that? You can clip whatever you want, Carrot Can. Alright, so we got our 1 of velocity there. Our character's doing kind of what he's supposed to. Our physics constants are totally screwed up. So the work I get to do is mostly farm work. Yeah, before college, I'm over in Spokane, which is like, you know, the more farm area of Washington. And all through high school, I was just building potato guns and flamethrowers and crap like that. And that engineering skill of, you know, being able to move stuff and do stuff in the real world does translate to actually very well to programming. Because it's the same logical process of like putting something together So, if you're working on a farm and you need to fix something, like all of that sort of skill and brain power really does help. Like it's all just logical problem solving. Even if one is computer programming stuff, it's still just common sense, engineering application work. So I think you do fine. C#, I would, if you're gonna start learning code, I would suggest learning, C and some more bare bones crap to start with. They started us off in C and assembly, but that's only if you're going to take like 4 years to learn it. Because a lot of the higher level languages, you will learn the spec of the language and all that stuff, and you'll learn the language a little bit too close. And it's better to get it's better to just learn how programming works on a lower level first, because then your brain is wired, and then when you look at a language, you're like, oh, okay, okay, JavaScript. This is how, okay, I can make a variable. We're done. I know this language now. Oh, okay, Python. This is how you make a variable. This is how you call a function. All right, we're done. I can write Python. Where you can just read a data sheet and just turn it into code, and it doesn't matter what the hell the code even looks like. It just, lol code. Okay, cool. Arnold Schwarzenegger code. Awesome. Get to the chopper is how we return from a function. We're finished. Anyway, I am getting really hungry here. So I think I'm going to go grab a snack and come back. So, bear with me for a couple minutes. Thanks for tuning in. Hello, and we're gonna get back to actually doing some work here. Oh, nothing happened to my camera. I was just, I didn't have it on. And that's my default image for no camera. Yeah, he frozen time. There we are. I can actually switch clothes immediately. It's a secret superpower I have. And also change the time of day. It's just so good. So much. Frozen in space and time. Yes, that is where we are. That's where we will continue to be. Yeah, it only works when I'm streaming with a 15-second delay. Yeah, instantly. I can instantly. That's something I actually have in real life. I can instantly become angry about something. I'd be a really good dark side force user because I just think about like all the horrible things that just exist, like puppies and kittens, and I just get pissed. God, how can those things exist? It's awful. Got pancakes? Pancakes are good. Gotta love it. So we're gonna get back into the physics stuff. The first thing we're gonna do is we're going to change our gravity constant. We're gonna make it a little bit higher, and we are going to we're gonna change how fast we move. And we're also going to set our ortho width to something a bit higher so that we can kind of see back farther. So where's our actual speed? Our camera follow speed also needs to be a lot higher. So we'll chuck that up. Alright, let's give it a shot and see how these constants look. And it is 5:30 in the morning here, which is an excellent time to be awake, because I really have no reason for that. It actually sucks usually having your schedule offset because then you're all angry about like, oh well, the store closes in 30 minutes when you wake up. You're like, ah. So that gravity is just not. That's not enough gravity, is it? We need more acceleration. So we're gonna do this gravity real quick, and then we'll probably the next thing we do is getting us to jump, because it looks like we got movement in the air working real well. Real well, as in it looks right, which means it's probably just all bullshit. Again, that doesn't look quite right, so we're gonna throw a little bit more into it. But it's cold out. Yeah. I have plenty of snacks. I just got my Japan crate delivered just today, so now I have all the little caramel corn from Japan that I could possibly stand to eat. That's how you know somebody's a nerd. They subscribe to Japan crate and crap like that. So our mantling stuff looks like it's, whoa, Oh no. Let's see if Batsack can. If we put him up here on this diving board, we just let him fall off. What happens? It's just, you know, he could just make it across those gaps. It looks like we're also getting stuck into stuff on the vertical wall. So a couple things. Gravity still seems to be... What we're going to want to do is we're going to have like a clamp magnitude for the gravity vector. We're going to have like a max, G max. But vertical speed... And then like a max horizontal speed. Gravity, I think, needed to check in a little bit faster even then, which might be a sign that we're applying gravity wronger. We're applying gravity wrong. Like we need to like square our delta t or something, and add that. Alright, so the wanted velocity size, we have that in there. We want to, we want to set our direction. So we're setting it to the 0 vector. So the other thing here is we're adding our new velocity to, our wanted velocity times our delta in our air control. And that's not what we actually want to do, because what this is going to do is our wanted direction, like we're adding in a direction that we want to go. But what if we want to not go somewhere, right? And what we actually want to do is we want to take our we don't want to add into our new velocity, our wanted velocity. We want to move to a specific kind of relative speed. So it should be our theoretical velocity. So our wanted velocity, we should basically take our we want to move towards our wanted velocity by a constant time, constant speed, and I'm gonna do this. Do we have the physics code for this already written? Let's clamp our stuff. So like if new f maths, let's see, abs of new velocity dot z is greater than our max vertical speed. Then we are going to set our new velocity.z equals our max vertical speed times the fmath sine of new velocity.z. We'll do the same thing with our y. Do that for horizontal speed. Excellent. So we got our stuff clamped. And how exactly? In the past I've done this with pretty different sorts of things. Do we have... I think it's in maybe math and not physics. So we've got these things like lerp int locked and lerp float lock and stuff like that. And basically what we do is we pass in a start and an end and then like a percent, or in this case lerp float dt is like start end t and then speed. And I think we want to call lerp float dt. And what this function does is it moves us toward a value that we want at a speed, and it doesn't overshoot it. So basically, like, our current velocity is our wanted velocity. Our current velocity is our new velocity dot y. So it's going to be like our start is our current new velocity, and our wanted velocity is, wanted velocity dot y. The t is delta t, and our speed is going to be our air control speed. And what this is going to do is it's going to give us a y value. So float y is going to be this. And basically we set new velocity.y to it. And this is a function I wrote back in college. Or at least based on some stuff I did in college. There's just, you just take your n minus your start. If your delta is 0, just return the end. Otherwise, you add the start, you add t times the speed times the sine of the delta. And then if the n minus start times delta is less than 0, then you overshot it, so return end. Otherwise, you return start. And we're just using the variables that are passed in. So that's our lerp float dt right there, and it just linearly interpolates a float based on speed and at time. It's kind of a convenience factor, like lerping and all that stuff. Usually you'd have like how far you want to go and all that crap. This one's just like, I know what you're doing. You're trying to do movement, so just do movement. And we need to add these to our global statics. And how is everybody's day going? Like I just woke up, fixed some problems with Adam had some stuff that was he wanted me to look at, like the scene he made last night in Unreal, which I think he toasted his stream. He didn't archive it, so I'll throw a little picture of that up in case people missed it. After we're done compiling. G vertical speed is, where are we getting angry? Over here? Well, that's because float is not spelled with a G, it's spelled with a T, isn't it? We're gonna floag. We're gonna floag all over this place. I do not know what that means. My day's going well, just doing work, relaxing. We actually did like decently last night playing Battle Brothers, and by last night I mean like yesterday morning, because I don't live in the same reality as most of the rest of the human race. We actually defeated the undead, or at least came pretty close to it. We're pushing them back, which is what matters. Administrative stuff, paying rent, yeah, and get back to course stuff. That's Adam's FX course? Awesome. Well, you can always contact me if that new website is having problems. So I think we got most of it ironed out. Like, we had a few SSL issues that were going on where basically WordPress is stupid. So that looks a lot better for the gravity kind of taking us into the ground. Yeah, using your computer again is important. So it looks like our lerp is just not working at all here. Or at least if it is, it's not working well. So attack is flying, yes. Crash. So I want to see exactly why our lerp is not working. Update in the air. New velocity plus equals gravity. New velocity at y equals y. We're doing it from wanted to this. Delta t is probably way too damn small. So let's see exactly what it's doing. So our new velocity y, of course it's not going to show us what's going on, but our delta is n minus start, so our delta is 0, so we're just going to return 0. All right. Now it's always 0. Our wanted velocity dot y is always equaling our new velocity y? That cannot be right. Both the end and the start are 0. Alright, so new velocity is -10, wanted velocity is 0, so okay, that works. End and start is again 0. I mean, it should just be wanted velocity dot y. Maybe we just need to use this instead of a vector. Well, that's what that animation is supposed to be that we're playing right now. The head bob is supposed to be when he impacts the ground. Well, we've got some other ones that are like for heavy impacts on the ground. Which is right over here. Is it? It's not right here. I lie. It's in here. Those are going to be his splat animations for landing. Alright, so the start is that, the end is negative 3,000. We're trying to get over to that. And we're moving in that direction. Our T is tiny and our speed is tiny. So what we're going to see here is real small. So we want it to be much, much larger. Air control needs to be basically how much we can get in 1 second is how much our air control is. So let's set it to 3,000. And once we get the basic air control in there, we can then we should make the jump actually jump, as opposed to just put fat sack 1,000 units higher than he currently exists. It looks like that's kind of what we want. I think we need a little bit more control. I like the idea of Fat Sack running downstairs so fast that he's skipping the steps. It's like bam, bam, bam. I'm Fat Sack. You ain't got shit on me. So we'll see how Fat Sack does climbing all these. Oh shit! Okay. Alright, let's see how he does going down these platforms. So he's like on the ground, and then these. Whenever he hits a seam, he just flies into space. Boom. Boom. And that's him not sticking to the floor when the slope changes. Kind of does things. Well, that's interesting. Why are we having problems with that? Because he's in the air. Yeah, he's got his little air grab there. It's not really working. Okay, so now we're going to want to be able to jump. That's what it looks like. So let's get our jump going on. And I think what we're going to need to do for a jump is basically we're going to change this the A action. Let's change this to, what is the S key bound to? Input mapping will tell me. So we've got our default key mappings, which I believe are all hard-coded here. We've got the B action is set to the S key. So we're going to set S to fling us in the air. And we're going to set A to jump. So this is going to be the B action. And this is going to be the A action. So basically what we're going to call is movement. And we're going to call, I think, jump on our movement object. I think we got jump as a function. Yeah, so jump in the direction and a velocity. So I'm going to call jump, and jump's going to need a vector, so it's going to be jump vector. I think that's going to be direction vector. So wherever you're holding, and the question would be like, which direction should jump actually take? I mean, either we're going to jump like